and John's going to give us an update on the ground to cloud. As Andy's been pointing out, the ground to cloud, cloud to cloud, cloud to ground group, or however you'd like to call it. John, take it away.
Thanks.
You're good.
So yes, there's a separate working group on ground to cloud, and cloud to ground. And really by cloud to cloud, we mean within a cloud. There's also people who talk about, what if half my workflows in one cloud provider and one half is in the other? And that's, I think, more like cloud to cloud again kind of thing. But anyway, so we've been meeting for some time. Early on, we agreed that there were a couple of different operating points that went with these kinds of essence transfers from the ground to the cloud and the cloud to the ground. There's kind of an interactive latency thing where you have, short GOP H.264 or increasingly maybe some UHD. And that's a pretty common use case. And then there's kind of the bandwidth optimized super long stuff, which has more latency and doesn't look as good. But that the new work was probably on the what we called the premium compressed tier. So having ultra latency production quality for a given value of production. And that's really where VSF TR08 and TR09 come into play, is this JPEG XS tier. So all to say, these are kind of the operating points. These haven't changed since the last time we reviewed the activity with the larger audience. There's really two cases. There's the interop points going from the ground to the cloud and the interop point going from the cloud to the ground. And those you can document as a stack of protocols all the way down to the IP packets with, something like TR08 and even TR09 covering some of the aspects of the transport, and equally the management plane of how do you set up that connection is something that's being worked in the TR09 activity. But within a cloud provider, there's a need for an interop point between instances. So if you wanted to build a workflow in a cloud that had, parts from different vendors, how would you send content from one part to another part in a way that's written down in a way that's mutually agreed? So that's what we've been really focused on the last many meetings of the GCCG group. Now, we did, of course, document some work for adjacent groups. So the requirements for the compressed ground to cloud and cloud to ground cases, those largely went off to TR09 and TR08, and they've turned into some work there. And those documents include interop points, so forth. For the middle case, the transport stream IP H.264 case, that case is in active use today, but there's not a lot of commonality or any commonality to my knowledge of the control plane of it. So potentially the control plane work we're doing could start to apply to that. Although given the control plane work leverages NMOS, I'll ask the question, it would be handy if NMOS had some interaction with transport streams, and maybe we can define that.
Amen.
Then for, within a cloud, and even if you go from the ground to the cloud to the cloud to the cloud to the ground, how do you keep track of time? How do you keep track of what the relationship and what the expectations are? So, on the ground, we have usually this rigid pipeline of frame times since the epoch that's dictated again by our SDI heritage, to Andy's topic earlier. But in the cloud, there's no reason to take that heritage into the cloud. So we've come up with a different way of tracking time that we'll talk about in a second. And then, of course, what's the actual format of the data when you're handing stuff off between software applications? So in this time discussion, we spent a long time iterating this drawing to get down to a point where we said, look, at each handoff, we have a time tag that is what time it was and whose clock it was. And that lets us keep track of the, where the content comes from and how it, what's its baseline of time. And then in turn came up with a way to describe the variability of that timing. And ultimately, if you have a process step, like say an H.264 encoder for distribution, that needs to linearize, needs to create an output that complies to, say, MPEG-2 transport stream, then it has to set up enough buffering internally to take whatever variability comes in and turn it into a smooth delivery. And so this process and model we've come up with give it the information it needs to make the decisions that it needs in order to do that job reliably. And in all these cases, we've tried to be realistic about requirements, like realistic that the time source in the data center might be traceable to GPS, usually is, but is going to be something like NTP, where it's not going to allow you to be accurate to the microsecond. And really, you have to ask yourself, why did you want to be accurate to the microsecond? And often the answer is so that you could create, reference back to SDI, but we're pretty far from that inside a data center. A big chunk of our work of late has been around this latency and variability spec, and saying that in a processing step, there's a minimum amount of time that it takes you to both do your processing and get your output off your dock. And then there's some variability of how much longer it might take you, depending on interrupts and other whatever crazy thing. And so that latency model of saying there's a minimum plus and 99th percentile worst case value is what we've kind of settled on as a way of modeling the variability and the typical. And then, of course, if you have an input with some variability, a processing step might make an output that's even more variable. Or a processing step might instead say, look, I'm going to buffer some and make my minimum latency a little longer, but have less variability in the output. And those are choices that a processing step can make. And all we really ask is that the processing step has to say what its output's going to look like. Because that spec of what comes out of a processing step becomes part of the contract. When you talk about, I'm making a thing that runs in the cloud, what is the contract at its input? And the contract is, what's the data content, meaning, what am I getting picture-wise or equivalent for audio? And then also the format, the details of how is that actually laid out in memory, and we'll talk about that in a second. And then, of course, this timing variability, because ultimately I have to know what's coming in order to meet my own specification on the way out. So that said, our current talk is in the meetings is actually about how to organize the data, literally the buffer handoffs from application to application, because there's a couple ways to do it. You could pack it up really densely like the P groups in 2110. That has the advantage of being well written down, but it has the disadvantage that it's not the native format of anybody. So everybody has to convert that into whatever their internal representation is. You could do something software friendly, like say, look, it's planar and it's in 16-bit chunks, even though I only use 10 bits. And that's great if you're at software, but it's kind of takes extra bandwidth on the network. Well, who cares? That's the cloud provider's network. There's probably some points in between to operate at. So that's a discussion that's going on right now in the group. And then in parallel with that, what is the metadata about the pixels or about the audio at session setup, and what is actually allowed to vary from frame to frame or from time to time in audio. So in terms of finishing up this activity, the transport specs for ground to cloud and cloud to ground actually are well underway in the other groups, as you'll hear. The connection setup as well as basically the work in progress of Tier 09. The content handoff spec cloud to cloud is the current conversation in our group and trying to get that to where we can document it. And then for connection setup, a little bit that's cloud provider specific, because the data handoff methodology is going to be different in different cloud providers. But there's parts of that also that should be ideally written down, at least the data object model of what describes the data should be done in a common way. So all that said, that's what's going on in the ground to cloud, cloud to ground working group. I yield the floor.
All right, excellent. John, thank you very much.